we have a large semicircle with diameter 4, two equal semicircles inside that are going to have diameter of 2, and then a small circle that fits in between them, and that's what we want to work out the radius of. So I'm going to put the centers of them in. This is the center of the large semicircle. This is the center of the smaller semicircles. It's quite often very useful to use these because then you get the radius or the radii of the different circles or semicircles. Now I can't avoid using, I'm going to create an equation here and I'm going to have to use the radius of the smaller circle. So let's call this little r. Just going to label that little r. This is a line that's gone directly up. That must be the radius because they touch right at the top. Okay, now I'm going to try and use these centers. So what I can do is connect the centers together. And that will mean that I've got the radius of the smaller circle plus the radius of the semicircle, which is going to be 1. So I've created a length, and I can do exactly the same on the right. And that's what you have to do in these sorts of questions. Just play around with it, see if you can create a triangle, for example. That's what I'm managing to do here. Sorry. Like that. That's what I'm trying to do. Okay, so R1, R1. And then this actually is going to be 2. That doesn't give a right angle triangle, but there's symmetry involved here. So I'm going to draw one more line in, which is really going to help. And that's to continue this vertical line down. Okay, so let's just backtrack to what the thinking was at the start of this question. Put the centers of the semicircles or circles in, just get them in. See if you can create a shape that's going to connect them. And in this case, it just seemed natural to connect them to create this triangle. We immediately got that one of the lengths of the triangle was r plus 1, and actually the other side was as well. So we've got two sides. It's an isosceles triangle, and then the base was going to be 2, but if we drop a vertical down it, use the symmetry of the problem, then we're going to create a right-angled triangle. If I just focus on the left-hand part, right, I've got a length of 1 at the bottom. I've got r plus 1 over here. All we need is the height. But remember, the radius of the large semicircle is 2 because the diameter was 4. And this length was r, which means that this length must be 2 minus r. I've got a missing piece of the puzzle. We can use Pythagoras' theorem now to link the sides together and create an equation for r. Okay, we're nearly there. So that's the hard bit. That's what you've got to somehow get to. There's lots of math challenge problems out there that do a similar sort of thing, just different setups. Try and get that right angle triangle. Okay, so 2 minus r squared plus 1 squared, which is just 1, is going to equal r plus 1 squared. Remember, this is a double bracket. I'm going to get r squared minus 4r plus 4 plus 1 is equal to r squared plus 2r plus 1. I hope I haven't done that too fast. I'll just show some working up here. Okay, I did 2 times 2, that gave me 4. I did 2 times minus r and 2 times minus r, that's how I got my minus 4r. I did minus r times minus r, which got me my plus r squared. That was the first bit. I then added 1 on, and I did this similar for the right-hand side. Okay, the great thing about this actually is that we've got r squared on the left and on the right. They're just going to cancel out. We don't actually have a quadratic. So let's just tidy it up. I've got minus 4r plus 5 is equal to 2r plus 1. So I can add 4r onto both sides, 6r. I can minus 1 from both sides. 6r is equal to 4. Therefore, r is equal to 4 over 6, which simplifies nicely to 2 over 3. Our answer is going to be A. Well done on your efforts.